Hello student, this is the first lecture of a transformer, and in transformer we are going to discuss about the definition of a transformer, then basic principle of a transformer, the symbolic representation, the winding identification of a transformer, then working principle of a transformer. Okay, so basically the definition is what a transformer is: a static apparatus which transfer electric power from one circuit to another circuit without changing frequency. So basically what is a transformer? A transformer is what? It is a static apparatus. It means it has no movable part. That is why the word static is used. Then as per its name, transformer, it transfer electric power from one end to another end without changing the frequency of a applied signal. Okay, this is what the basic definition of a transformer. Then the basic principle of a transformer is it is based on the law of Faraday's law of electromagnetic induction, that is E is equal to m di by dt, and di by dt is what? It is the rate of change of current and which produces the flux. So basically flux is what? It depends upon current. Okay, and m is what? It is a mutual induction. We'll discuss each and every term one by one. The third point is what? It is, this shows the symbolic representation of a transformer. Basically what is it consist of? It consists of a core. This is what the core is. The core consists of two legs. This is number one, this is number two. On the legs, windings are one out. Okay, so now it is on one of the leg there is one set of winding, on the another leg there is another set of winding. So now the thing is what? How we will identify which one is the primary winding and which one is the secondary winding. Now how we have to identify which one is the primary winding and which one is the secondary winding? See, this is what the core is and this is winding. These are what? These are the windings. Okay, now suppose if a source is connected to, suppose this is one circuit, this is another circuit. If suppose the source is connected to this circuit or one circuit, then it is known as primary winding. And this is what type of source it is? It is a AC source. Okay, whose equation is given as V is equal to Vm sine omega t, where V is a what? It is a small v, instantaneous voltage. It is maximum voltage. Then AC is having a sine function waveform, and omega is angular velocity, which is given as omega is equal to 2 pi f, and t is instantaneous time. Okay, so when and here in this circuit, if load is connected, then what will happen? It is what? It is a load, so it will called as a secondary winding. Which one? This winding is known as secondary winding, whereas this winding is known as primary winding. Why it is so? Because in this winding AC source is connected, so it is known as primary winding, and in this winding load is connected, then it is known as secondary winding. If suppose here, if AC source is connected and here load is connected, so what will happen? Then at that time this winding will become the primary winding and this winding will become secondary winding. Okay, it means if the winding is connected with the source, it means it is a primary winding. So as per the statement, if the AC source is connected to one of the winding of a transformer, then the winding is known as primary winding. If the load is connected to the other end of the winding, it is known as secondary winding. Okay, so likewise we can identify the primary and secondary winding. Means if source is connected, where the source is connected, that is a primary winding. We can represent it by using 1 degree primary winding. And if load is connected, it means that is what the secondary winding. Okay, now the next topic is working principle of a transformer. So here in this figure, the source is connected to this winding, so let it be, this is what the primary winding, and the load is connected to this side, this is what the secondary winding. Okay, here this is the primary winding, which is having a number of turns, let it be n1. N1 is what number of turns in primary winding. Similarly, these are what number of turns in secondary winding. Number n1 is what number of turns in primary winding, n2 is what number of turns in secondary winding. Okay, now why this is called as primary? Because the source is connected to this side. This is what the AC source means. It is having sinusoidal in nature, means the nature is what keep on changing. Now when this is connected, the source is connected, there is a flow of current I1. Let this current is known as exciting current. This current will start flowing into the winding. So what will happen when there is a flow of current in the winding? There is a production of flux phi. Okay, this flux phi is what? Phi is coming from current I1. How phi is set up? Because of current flowing I1 into the primary winding. Okay, and the nature of current is what? It is keep on changing. So in this circuit, these are what? These are coil or conductor. It means conductor is stationary, whereas magnetic field or flux, it is what? Changing. Okay, magnetic flux is what? This is what the magnetic flux. Magnetic flux is what? Changing. And conductor is what? It is stationary. Conductor or the coil or the winding is what? It is stationary. So what will happen? There is a induced EMF according to Faraday's law of electromagnetic induction. So there is, in this winding, there is a production of or induced EMF as per Faraday's law of electromagnetic induction. But according to Lenz's law, what will happen? This EMF will oppose to this voltage V1. This voltage V1. Okay. It will oppose. Why? Because of the Lenz's law. Now in this winding, the flux phi is set up. This phi will travel through this path, this iron core path, and link with the secondary winding of a transformer. Some of the flux जो है, that will leak out, that will follow the other path, known as, this flux is known as leakage flux, whereas the flux which is linked with the secondary winding is known as useful flux. Now the secondary side, what will happen? This flux phi is linking with the secondary winding N2. What will happen? Flux phi is keep on changing. This conductor is stationary. There is production of or induced EMF E2. So at this terminal, at this point, this E2 is equal to this, and this is what the terminal voltage V2. If no load is connected, it means E2 is equal to V2. Okay, and the current flowing through this circuit I2, when no load is connected, I2 is what? It is 0. I2 is 0 because load is not connected. But when at no load, E2 is equal to V2, whereas I2 is equal to 0. Now when there is a connection of load at the secondary terminal, what will happen? There is a setup of current known as I2, and I2 is known as secondary current. Okay, clear? This is what the basically working principle of a transformer. So once we revise it, what will happen when we apply AC voltage V1? V1 is applied, there is a flow of current I1, and because of this I1 there is a flux phi set up in the primary winding. Because of this flux, it is changing in nature, and conductor is stationary. There is a production of EMF or induced EMF E1, and this EMF opposes the V1. Why? Because of the Lenz's law. This is what the primary circuit. Now moving towards the secondary circuit, this flux is linking with the secondary circuit. So flux is what? It is keep on changing. Conductor is stationary. There is a induced EMF E2. If the terminal is not connected with the load, E2 is equal to V2 and I2 is equal to 0. But when there is a connection of load, E2 is not equal to V2 and there is a setup of I2 current in the circuit. Okay, this is what the basic working principle of a transformer. So we can summarize that, or in brief, a transformer is a device that transfers electric power from one circuit to another circuit. First point, it does so without a change of frequency, means there is no change in the frequency. If the energy is transferred from one side to the another side, it accomplishes this by electromagnetic induction. The whole process of transferring is done because of the mutual induction of